In this video, we are going to look at Mathematics 1503, that is linear algebra. We are going to focus on vectors. Today's lesson, we are going to look at dot product. Let us start. In earlier mathematics and physical sciences classes, we have learned that a vector is a physical quantity with both magnitude and direction. Now, in tertiary level or later on classes of physics and mathematics, we tend to describe a vector in a more detailed manner. Now, vectors in mathematics, also known as Euclidean vectors, are represented in this manner. You can see it's a coordinate form. We normally say it's R2 or two-dimension vector. We use coordinate form, or we can represent vectors using this manner. You can see that the difference is that this one consists of 3 coordinates, and then we say it's a 3-dimension vector. We also have a vector like this. So you can see that we can represent vectors using different types of dimensions. Since we know different types of vectors, let us go straight to today's lesson, which is dot product. I just wanted to give you a simple brief introduction of what is a vector. Now, from earlier classes, we know that this is x, this will be y, this will also be x, this will be y. Let us actually say this is x2, y2, this is x1, y1. Now, what is the dot product? We should be able to know that this is not the same as this. We know that earlier on in mathematics and physical science class, we know that 3 multiplied by 2, it's actually the same as 3 multiplied by 2. Looking at the 2, we can see that in this case we use the multiplication notation as a cross, and then this one as a dot. Now these two are actually different when it comes to Euclidean vectors. This one we say it's a cross product because we can see that the sign is cross. This one we say it's a dot product because we are using a dot. So today's lesson is based on this one. The next lesson will be based on cross product. So we have vector A and vector B. Remember, this arrow simply represents that we are dealing with a vector. If you see something like this, you should know that this is a scalar quantity. Now, what is the dot product of A and B? It's actually simple. The dot product of the two will be x1 multiplied by x2 plus y1 actually multiplied by y2. That is the equation. Now looking at this one, we are going to have 3 multiplied by 4 plus 10 multiplied by 9. And then 3 multiplied by 4 is 12 plus 9 multiplied by 10 is 90, and then our answer will be 102. So you can see that the dot product of two vectors will actually give us a scalar quantity. You will see on the next video whereby we look at cross product. The cross product of two vectors, the answer will always produce another vector, and then the dot product of two vectors, it will give us a scalar quantity, which is a value. The second example, find the dot product of the two vectors. Pause the video, try to work out and see whether you understand. Now we said this will simply be 4 multiplied by 17 plus 2 multiplied by 4. 4 multiplied by 17 is 68. 2 multiplied by 4 is 8. The answer is 76. Now you can see that for this example we are actually dealing with two-dimension vectors. Now let us look at three-dimension vectors. How do we actually solve them using the dot product? Our two three-dimension vectors. Now the first question, what is the dot product of vector u dot product of vector v? Now as you all know, it will be 0 multiplied by 1 plus negative 2 multiplied by 3 plus 2 multiplied by negative 1. So we have 0, negative 2 multiplied by 3, it's a negative 6. 2 multiplied by negative 1, it's negative 2. So the answer is negative 8. The second question, what if we look at the vector of v multiplied by the vector of u? So we're going to have 1 multiplied by 0 plus 3 multiplied by negative 2 plus negative 1 multiplied by 2. So we have 0, negative 6, negative 2, and then negative 8. So we can conclude that, vector u multiplied by vector b, it's equals to vector v multiplied by vector u. With the given three-dimension vectors, vector a and vector b, find a dot product of b, or the dot product of both of these vectors. So this will be negative 3, 4, plus 1, 0, plus 2, negative 8. So negative 3 multiplied by 4, we have negative 12, 0, and negative, let us just simplify this, negative 16. We get negative 28. That's it for this lesson video. This is Wahula AJ. Thank you very much.